Welcome back to module 7 of this unit 2, permutations and combinations, and we will be talking about some properties of binomial coefficients in this module. Just to recall, we have defined combinations the previous class, and NCR, it is the number of ways R objects can be selected out of n. It is given by n factorial upon R factorial into n minus R factorial. So basically we talk about selection, and we are selecting R objects out of a total of n objects. Now we have already seen that while we calculate NC0 for all values of n, NC0 is always equal to 1. Okay, NC1 is equal to n, NCn is also equal to 1. So this NC0 and NCn both are equal to 1. NC1 and NCn minus 1, these both are equal to n. Okay, so NC0 is same as NCn and NC1 is same as NCn minus 1. Okay, if you see, NC0 is the first term, okay, for R equal to 0, and NCn is the last binomial coefficient for R equal to n, the highest value here. The same way NC2, which is, if you recall, NC2 is n into n minus 1 upon 2, which will be same as NCn minus 2. Okay, so because of these values, these properties here, if I just write down all the binomial coefficients for a value of n, okay, for any value of n, if I write down all the binomial coefficients NCR, now R can take all the values from 0 to n. Okay, smallest value 0, highest value n. So if I write down all the binomial coefficients NC0, NC1, NC2, NC3 and so on, okay, NC0 is always equal to NCn, which is equal to 1. NC1 is always equal to NCn minus 1, which is n. NC2 is always equal to NCn minus 2, which is n into n minus 1 upon 2. We have already calculated. So the same way, NC3 will be same as NCn minus 3. NC4 will be same as NCn minus 4 and so on. What we have is a perfectly symmetric coefficients here. Okay, I can divide them in exactly half, where one part is just the mirror image of the other one. So if I have to find out all these coefficients, I don't have to calculate all of them. I have to know only half of them, because the other ones are just the mirror image of these values. Okay, so in general we can write down NCR is same as NCn minus R. NCR is equal to same as NCn minus R. And that's all. So all this that we have just talked about, we have put it into a general form like this. Okay, now this is a very important result, because sometimes when we are solving examples of this type, let's say I want to we are given that C18R or 18CR is same as 18CR plus 2, and based on this we have to find the value of R. Now if I have to manually solve this, 18CR is 18 factorial upon R factorial into 18 minus R factorial, and 18CR plus 2 will be 18 factorial upon R plus 2 factorial into 18 minus R plus 2 factorial. So I'll have to solve this. I'll have to cross multiply, and then you'll arrive at a second quadratic equation maybe, and then you'll have to solve this quadratic equation to find the value of R finally. Okay, of course you can find it out, but then because I know this property of binomial coefficients, that NCR is same as NCn minus R, I can very well use this property in solving this example. Okay, and in a much lesser time. Now here n is equal to 18. So if I say if I have to write down all the possible binomial coefficients, okay, NCR, basically 18CR, then this R can take all the values from 0 to 18. Okay, so if I just write down all the values of R, I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So if I have to write down all these coefficients, we know that because of the symmetricity, okay, this is corresponding to 18C0, this is corresponding to 18C1, this is corresponding to 18C2. Okay, the same way this is 18C18, this is 18C17, this is 18C16. Now because of that result NCR equal to NCN minus R, we know that NC 18C0 will be same as 18C18, 18C1 will be same as 18C17, 18C2 will be same as 18C16, 18C3 will be same as 18C15, 18C4 will be same as 18C14, okay, 18C5 will be same as 18C18, sorry it is here, okay, 6, this coefficient will be same as 12, okay, 7 to 11, 8 to 10, okay, so and this 9 is alone here. Now if you look at this 18CR and 18CR plus 2, now R plus 2 and R, we are looking at those coefficients which are at a distance of 2, R plus 2 and R, they are at a distance of 2. Now which are the coefficients here which are same and which are at a distance of 2? Okay, like 0 and 18, they are at a distance of 18. Okay, the same way 7 and 11, okay, they are at a distance of 4. 8 and 10 are the ones which are at a distance of 2. Okay, so R is equal to 8, in that case R plus 2 is going to be 10. So by using this property I am straight away saying that R is equal to 8, and that is the answer for this. Okay, so instead of solving it manually like this, I am using this property in finding the value of R. Another property of this binomial coefficient is this, okay, that is CNR or NCR plus NCR minus 1 is equal to N plus 1 CR. Okay, this is the property. This is also useful while we are computing some sums like this. Let us say I wish to find out what the value of 18C5 plus 7C4 plus 6C3 plus 6C2. Okay, now if you see this property here, NCR plus NCR minus 1 is N plus 1 CR. So if you look at 6C3 and 6C2, if you take N is equal to 6 and R is equal to 3, okay, if R is equal to 3, then this is R minus 1, that is 2. So this is perfectly in. So 6C3 plus 6C2, they are like NCR plus NCR minus 1, which is N plus 1 CR. So 6C3 plus 6C2 with N equal to 6 and R is equal to 3 will be equal to 6 plus 1 CR. R here is 3 that we are looking at. So this is 7C3. So instead of finding it manually by using the formula for combinations, I can straight away say that 6C3 plus 6C2 is equal to 7C3. So this sum is finding just this sum. Now again 7C4 plus 7C3, again if you look at this, this is again in this form with N equal to 7 and R is equal to 4. So 7C4 plus 7C3, okay, it is like NCR, in that case this is NCR minus 1, this is going to be 7 plus 1 C4, N plus 1 CR. So this is 8C5 as it is. This both sums can be replaced by 8, this is 7 plus 1 C4, 8C4. Finally I'll end up at 8C5 plus 8C4. What I have to do is again use the same formula here. This is now NCR plus NCR minus 1 with N equal to 8 and R equal to 5. So 8c5 plus 8c4 is 8 plus 1 c5 by using the same formula that we wrote here. So in that case this will be 9c5. So instead of finding all these 4 terms individually and then finding the sum later, all that you have to do is find out 9c5, and 9c5 we already know that it is equal to 9 factorial upon 5 factorial into 9 minus 5 factorial. You can simplify this and then find the value. Okay, so this is how these properties of this binomial coefficients are going to be useful to us.